Okay, so we're doing a little warm-up of questions you got to know for our next couple tests that we have next week. Um, and this is going to focus on, well, a lot of different concepts, actually. This particular one, you got to get that absolute value alone first, and then you can split it into two parts. So, first thing, add 5 to both sides. Then, divide by 3 on both sides. Now I can split it. X plus 2 equals 4. X plus 2 equals negative 4. Then subtract 2 from both sides. X equals 2. Subtract 2, subtract 2. X equals negative 6. Now, are there times when you might want to take the time, like your life depends on it, you want to make sure you're right? If that's the case, then you go back up and put these numbers in. See if 2 really works. Put a 2 there. What's the absolute value of 2 plus 2? 4. What's 3 times the 4? 12. What's 12 minus the 5? So did it work? Yes, it worked. And the negative 6 would also work. Are there times when you will make decisions where people's lives depend on it? Yep. I'll give you an example. There was a air show not that long ago in Reno. Did you guys hear about the crash?
Yeah.
It was a plane, P-51 or something like that. It was a warplane, and that was what the U.S. was flying back in World War II. And anyway, this old warplane had been kind of fixed up to be in a race, and it was all working fine until it wasn't. And what happened was they just figured out now why this plane crashed. When he was doing the stuff that he was doing, it was flying at very high speeds and stuff. All of a sudden, the seat must have broken because the pilot, who should be visible in the cockpit of the plane in the little bubble that sticks up on top of the plane, goes like this, and here's the front of the plane, and then here's this thing sticks up like this. You're supposed to be able to see the pilot's head right there, okay, against the seat. And even if he was passed out, you'd still see his head there, like slumped over, because they're all strapped in. Okay, so even if he passed out, that would have not explained this. He was gone. There was no pilot. It was just empty. How could he have been gone? It's because his seat broke. That's their best explanation. And his seat then fell back here with him strapped to it, and the controls are up here that you're supposed to have in your hands. Okay, so he could not reach the controls anymore. So if you're flying at like 500 miles an hour and all of a sudden the seat breaks, you're going to have problems because now you can't reach the controls anymore. And it's like in your car. Okay, you're driving your car at 500 miles an hour and all of a sudden your seat breaks off and you're in the back seat. You think it's going to be hard to drive the car? It's almost impossible. Okay, you can't reach that far, especially if you're still strapped into the seat that's broken off. So bottom line is the dude crashed into the crowd, and the people that got hit by the plane, the 10 of them died, and then the people that were nearby that all got sprayed with a fine mist of jet fuel. And at that moment, normally when the plane crashes, what happens? An explosion starts a fire. Okay, in this case it was almost like a miracle there was no fire. I mean, that could have been so much worse. Can you imagine being sprayed with gas and then lit on fire, basically? I mean, if that had gone, it would have gone up in a huge explosion. All these people that were sprayed with gas would have been on fire instantly. So it could have been way worse. So anyway, it's interesting to find out that flaw in the seat, all it takes is something like that, and not only cost this guy his life, but all the people that he hit on the ground, and it could have been way worse. If he would have hit the grandstand, he probably would have killed like 200 people. Because if it hit that grandstand, there was so many people really close in, and with the gas, and everything, it probably would have exploded if you hit the grandstand and all the metal. Anyway, so sometimes your life depends on problems. In this class, it won't depend on them, but it wouldn't be too dumb to check anyway. All right, here we go. Write this one down. It's a little different. Here, it looks easier. But it's not. Why? Because it's got a less than sign in it. So all of a sudden, you're going to have to get the same answer you got before, but this time put it on a number line and test the regions, the little intervals on the number line, and see which ones work. Sorry, less than 4, and x plus 2 greater than negative 4. Notice when I changed to negative 4, I had to switch the sign around. Okay, now, subtract 2 from both sides, x less than 2. Subtract 2 from both sides, x greater than negative 6. Now I'll put my little graph number line up, negative 6, 2. Does it actually work at negative 6? Well, if I stick in a negative 6 here, you'll find out it's 4. Is 4 less than 4? No. How could I have known it wasn't going to work just by looking at this sign? It's not equal to, exactly. If that ever says equal to, then the numbers would have worked. But it doesn't, so they don't. Now I need to test the little different regions. I have a region down here, like negative 10. Would check that, see if it works. So I stick in negative 10. That would be negative 10 plus 2 is negative 8. Negative 8, the absolute value is 8. Is 8 less than 4? No, doesn't work. And I'm guessing it doesn't work here, and therefore it probably does work here. Did anybody test a region in there? Test a number in there? And did it work? All right. So then you should be saying it's from negative 6 to 2. And does it have a parenthesis or a bracket? Parentheses. Parentheses are if it's like an empty circle. It means that the number does not work. Okay. How many of you understand this kind? All right, good. Yes. You can, yes, on the graph, you can put parentheses like this instead of the open circle. You know why I like the open circle better is just because I don't know which way to put the parentheses. Because if the numbers had worked on the ends, then I'd want my parentheses like this. You know what I mean? But if it works in the middle, then I want my parentheses like this. So I like to put the open circle to hold the spot, kind of. And I'm not going to be grading this part near as much as grading this part. And of course, you do need to show your work, but if you'd used an open circle on the graph, I'd have been fine with that. As long as your parentheses versus brackets are right in your end answer. All right, moving on. This one, I don't even want to have you do, just look. If I add 9 both sides, I'm going to get 30 here. Now, what do you think the common mistake is that people do right now? They either subtract 5 or they, what would be really bad, at least they should know that it's divided by 5, so they should times by 5. But they shouldn't times by 5 either right now. Why not? Because you got to split it first. And people think for some reason that you got to get rid of this bottom part and then split it. Nope. It's got absolute value. That's all alone now. There's nothing left because I got rid of the 9. Now is the time to split it into 2. 4x minus 3 over 5 is equal to 30. Or 4x minus 3 over 5 is equal to negative 30. And now I can multiply by 5 on both sides. But don't do it too early. All right. Next thing. Use algebra to solve that. All right. That means you're not supposed to graph it. There are 2 tests. One's Tuesday, one's Wednesday. One of them, your calculator's not allowed. So if you were asked to solve this, you'd have to know some other way besides graphing it on both sides and seeing where they cross. So my first thought is, get this part alone, just like last time. Then divide by 2 on both sides. Cancel, 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 and this is crucial. 2 goes in here once, 2 goes in here once, 2 goes in here 3 times. X plus 3 over 1, which is x plus 3. This is one of those reasons this class is hard. It's because you got to know things like how to simplify that. Just in the middle of a bigger, much more complicated problem, you got to know how to simplify that stuff. What can cancel and what can't? Okay, so now I got my square root alone. Do I split it into two parts? No, that's absolute values. How do you fix square roots? You square them. And now we'll see if some of you guys make the common screw up here. The common screw up is to do this. Why is that not x squared plus 9 at the end? Because it's really, that's what squared means, right? And if I do that with first outside inside last, I get x squared plus 6x plus 9. You need that 6x, otherwise you're messing it up. And now, something I don't think I've probably like stressed enough is that when you have this kind of a problem, you got to get the one side to be 0. You got to get quadratics alone and then equaling 0. So I'm going to move these guys to the other side. And now I'll have 0 is greater than x squared plus 14x plus 5. And now you might be tempted to try to, oh, did I screw up the 5? It's not 5. What is this supposed to be? 13, thank you. Now at this point, since it said use algebra to solve, then I can't graph it. So, factor it. This one will factor. If it hadn't been able to factor, you'd have to be able to pull out the quadratic formula and use it right. So now I know how to factor. Again, a little thing that you have to know well to have a chance in this class. That's why I was telling people that couldn't factor that, okay, it's time to either buckle down and do a lot of catch up or get out of there because it's going to get really complicated. But it's really not that hard if you know how to factor. So now the answer is x equals -1 and x equals -13. But I'm still not done because it's a greater than sign. So then I got to graph those things and find regions and test them. Oops, -13 and -1. And now it's either going to be this zone in here, or it's going to be out here, or it's going to be out there. One of those three or two of those three are going to work and the others aren't. And your final answer will be to put all of that into a like parentheses and brackets. It's called interval notation. All right, testing. -2. If I test -2 and see if it works. -2, -2. This part would be -1. This part would be 11. That makes -11 is 0 greater than -11. Yes, it is. So it works. Do my endpoints, the -13 and the -1 themselves, do they work? No, because this isn't an or equals to sign. So they're not going to work. If you wanted to, you could test them. Stick -1 into the equation and you'd find out it doesn't work. Empty spot here, empty spot here, filled in there. If you test these, you'll find out they don't work. Final answer, -13 to -1 with parentheses. Any questions on that one? Okay, so let's try some more kinds of problems that you might have trouble with. This one says use graphing. That means you specifically have to graph it to solve it. So grab a graphing calculator. If you have to borrow mine, make it fast. And I've already got them in on my calculator. Go ahead and type that in. 5, and then the square root sign, 4x plus 20. And then -5. It's not under the root, nope. So if you want to get out of the root, if you're like in a root and your calculator and you want to get out of it, you hit the right arrow, and that gets you out of the root, and then you can put -5. And when you actually hit graph, you may not have yours look as nice as mine. Yours probably is on the standard zoom, which is zoom 6. So I'll show you what that'll look like. You're like, okay, I see two lines, but I don't see where they cross. My best advice is try some of the major zooms. Zoom 6 is a good one. Zoom 0 sometimes makes it easier to see stuff. Try zoom 0. It's known as zoom fit. Now I can see where they cross, right? Now what if I want to get a better view of that area right there? Well, I can Z-box. I can use Z-box, which is a zoom box, and then sometimes it helps to see Z-graph. Get it? Z-box. Okay, now I'm going to move my little plus sign, and I'm going to form a box by hitting enter, and then move my plus sign around the area that I want to see. See how I make a box around it? And I hit enter. And it zooms in just on the part that you want to see. Now I can see them really well. And now my two lines, where are they crossing? I would use second, calculate the intersections, which is number 5. I get on the first line, see the little spiders blinking on the first line. I hit enter. Now it's on the second line. I hit enter. And now it says guess, and that means kind of move over to be right near where you think it crosses. And it'll make sure that if there is 2 places it crosses, that this is the one it gives you. I hit enter, and I have my answer of 0.936. Notice there's a y number too, but in the problem we only have x's, so that's what we want, is the x number. So the x number is 0.936. So, on my number line, how come I only have 1 point? All the other ones I always had 2 points. Sometimes quadratics, this one if I had solved it by squaring both sides I would have got a quadratic. Sometimes quadratics only have one answer. Remember these? Only touches once. You can have only one answer then. It's actually the same answer twice, but it doesn't change things that there's only one number that works. So sometimes quadratics only have one answer. It's a double answer. All right, so 0.936. Does the 0.936 itself work? You can look at that and say, what? Yes, it works. And now, is it the things that are bigger than that or smaller than that that work? Test something bigger than 0.936, like what? Well, you could try 1. The problem is you're going to have the square root of 24 to do, and that's not so nice. So I would try the number 4. Now why? Because then 4 times 4 is 16, plus 20 makes 36, and the square root of 36 is 6. See what I mean? I can pick any number I want over here, so I might as well pick one that works nice. And then it's 6 times 5 is 30, 30 minus 5 is 25. Is 25 less than or equal to 10 times 4 plus 10? 40 plus 10 is 50. Is 25 less than or equal to 50? Yes, it is. It works over there. And if you try any number smaller than 0.936, you find it does not work. So your answer is 0.936 to infinity with a bracket here and a curve there. Why a bracket? Because 0.936 itself works. Now, if you actually type it in there, it won't exactly work because we rounded 0.936. You got to remember that. So if your answer gets really, really close to right, that's probably right. Okay. This kind, the only reason I bring it up is because sometimes kids get so focused on quadratics, then when it's not a quadratic, then they don't know what to do. This can still solve by graphing, even though it's a cubic. What if it touches 3 times? Well, it's got 3 answers. And then since it's a less than or equal to, you check those 3 answers and check all the zones in between them. You have to test in between here, and in between here, and in between here. There's actually 4 zones that you'd have to check if it's got 3 answers. Yes, you can solve it algebraically too. First thing you do is, if you wanted to solve it without a graphing calculator, you'd go x comes out of it, and you have x squared plus 2x plus 1. And then add factors. how I factored that? And now I've got 3 answers in theory, but this answer right here is x equals 0. This answer right here is x equals -1. And this is the same answer as it was before, so I don't need another -1. So I guess I'm wrong. There's only 2 answers on this, because sometimes you get a double answer. So the only 2 answers here are -1 and 0, and then I test this zone, test this zone, test this zone, see where it works. And I think this is a tricky one. I'm pretty sure that I tested this one in the other classes and found out that it works in here. First of all, it works on the endpoints because it's an or equal to sign. Then I'm pretty sure it works in here. And the thing that kind of surprised us was that it also works out here. I'm going to prove that to you. I'm going to try like -2. Let's see if it works. -2 cubed plus 2 times -2 squared plus -2 is less than or equal to 0. The first part comes out to -8. That becomes 4 times 2 is 8 plus -2. And then the first 2 cancel, makes 0, so it's -2 is less than or equal to 0, and it works. So it works here also. So remember how I said it usually will be either both ends or the middle? In this case, it's the middle and one of the ends that work. So you're never going to really be able to trust that. You'll always have to test. Okay, then how do I write the final answer? You'd want to say from -infinity until when does it stop working? 0. Does 0 itself work? So do I use a parenthesis or a bracket? Bracket. And that doesn't work after that, so we're done. Any questions on that one? All right. Now what we'll be going through there was, maybe that last one was tough enough to qualify as an R3 or a harder AB kind of level question. But the rest of the problems that are AB kind of questions are going to be word problems. So you don't want to think in terms of, well, I can do everything except the word problems. Well, then you're going to get a C. Because the word problems are going to be the ones you need to get right to get an A or a B. Again, you can get 1 or 2 wrong and still get a decent score. But if you can't do word problems, then you won't get an A or a B. All right. To do word problems, my first piece of advice I tried to give you yesterday through that video was to draw a picture. This is a giant rectangle. So would you please put a rectangle on your paper? Next, read this. Sometimes you have to read it twice to make sure you understand what they're talking about. All right, so is it really a rectangle? Yep, it's a rectangle. So I drew a right picture. Now, can I put more on my rectangle? Do you know more about the sides than just that it's a rectangle? Yeah, you know more. What else could you tell me? Yeah, I know something about the dimensions. Do I know exactly how long they are? No. If I knew that, I'd already be done with the problem. But I know that it's like, I could say it's X and Y, but what would be even smarter than that? Not 5 times X. 5 feet longer than the other one. There you go. Very good. Next thing. You know that area is length times width. If you know that, then write area equals length times width on your paper. And then you always start with a general equation like that. Then you plug in the things you know to be true. Like, don't we know the area? What is the area? 120. And don't we now have something better to put in for our length and our width? Yes, we have. What's the length? Take the numbers from the picture and put them into your formula. X plus 5. And our width? X. Now, if I can solve this equation, I will be able to get my answer. So that becomes 120 equals x squared plus 5x. Then I subtract 120 from both sides. 0 equals x squared plus 5x minus 120. And then I don't know how to factor that. Pretty sure it doesn't factor. So what would you do next? It's not factorable, but does that mean you're done with the problem? No. You try the quadratic, or if you can use a calculator, I'd graph it. All right. Yes, sir. One of your two tests, you're not allowed to use a calculator. We'll tell you on the day of which one's which. All that you need to know right now is you need to know how to use a calculator, because one of your tests, it's going to be really handy. All right, so on this part, if I wanted to do it with the quadratic formula, I go negative b plus or minus the square root of b squared minus 4 times a times c, oops, all over 2a, which is 2, and that's such a pain in the butt. So did somebody already get it with either factoring or graphing? Why don't you try graphing this one if you haven't already? One answer is like negative something. Negative 13 point something. Okay. And the other one's positive. What is it? You guys got the other one yet? Single digit number, I know that. Isn't it 8 point something? 8 point what? 8.7. All right. Now I ask you, go back to the original question. What were we trying to do? Trying to find out how long sides of a rectangle are. Do you think that one of the sides is negative 13? You see how that doesn't make any sense? Therefore, that's extraneous. Anytime you get an answer that just doesn't work in the real world, you cross it off. Watch out for those. There are extraneous answers all over the place. You'll get two answers. You got to check them because one of them's going to not work. All right. Then the 8.7 must be it. So I just go write 8.7 on my page, and I get it wrong because it didn't ask for that. It asked for what the length should be, and the 8.7 is this number. So what's the length? It's 8.7 plus 5. See what I'm saying? There's so many places where you could screw this up. You could be done and think it was 8.7 and you did all this work and you got a right answer, but you didn't actually answer the question. What length would maximize the size of the rectangle? So I don't use this. That's the width. That's the length. So it's 8 plus 5 is 13.7. If they asked for the dimensions, you would have said 8.7 by 13.7. All right. So the moral of the story is, whenever you have a word problem, figure out what you could do to draw a picture of it. Then label your picture as best you can from the information they give you. Then write out a formula that you know goes with it too. And then transfer your info into the formula, like when we did this part right here. We stuck in the area was 120, the length was this, and the width was that. And then you'll have to solve it. A lot of times they're quadratics. Once you're done with them, a lot of times you have two answers. One of the two might not work. And of the ones that does work, you got to make sure you actually answer the question they gave you. What length? So we wanted this answer, not that one. Okay. This I only put up here because I don't think I stressed this enough before. When you're solving a quadratic, how do you start? Always. Getting it equal to 0. Yep. So I'd have to subtract 9 from both sides to get this one equal to 0. Now I can try factoring it. I can try graphing it. I can try a lot of things. All right. Good enough. Describe situations I warned you about where we might encounter extraneous solutions. I'll give you a couple quick examples. Real world. Anytime we say real world problems, you better make sure that your answer makes sense. So if you like say, how many apples should Jimmy eat? And it comes out to negative 12 and 7, throw out the negative 12 because it makes sense. All right. And the other place you have extraneous a lot is square roots. Why could that not be 2? X equals 2. It's an answer I came up with, and then I got to throw it out. Because why? Because when you actually stick it in, you'll end up with a negative on the square root. So watch out for square roots on extraneous. The last thing like that I wanted to talk to you about was if you are ever doing a problem like this and you take the square root of both sides, what are you supposed to watch out for? Plus or minus. What you're really getting is the absolute value of x is 4. And then you can split that into 2 answers, x equals 4 and x equals negative 4. Don't forget that. Whenever you do square root of a variable, it comes out to absolute value. All right. Here's one. It's a regression. I know you know how to do those when I give you the info in a table, but what if they don't give it to you in a table? Well, then put it in a table. Take the info they gave you, put it in a table first, and then you can put it in your calculator. So, and this is year, and this is money. In 2001, it was 14,000. Well, that sounds like the points that go together, right? 2001, 14,000. In 2002, it was 16,000. What if they gave you a year, like 2003, but didn't tell you how much it was worth? Can you put that in the calculator? No, you can't. Because if you put in a 0 here, it's going to imply that the value of your thing, whatever it is, a boat or whatever, went to 0 that year. That doesn't make any sense if there's more info later, like in 2005, it was 21,000. So don't assume this means 0. Just don't put in a data point that doesn't have anything with it. Like, in 2003, we never checked the value, so we don't know what it is. Well, then don't put it in. From here, do you know how to put these in? To everybody right now, hit stat. Hit edit. You got stuff in your list? Don't even have to type in all my stuff. If you want to, you could. Don't have to. Then, remember there's key sequence from here. You hit stat, and then what? Calculate, and then what? Linreg, and then what? Hit enter one more than last time. And it gives you this equation. Is anybody fast enough? They already typed in my data? Cool. What was the equation then? Perfect. All right, and I know sometimes these numbers are ugly, and in the real world they are. They're ugly numbers, but this is a powerful equation now. Now, if they tell me a year like this, I can put it in. I either put it in here or here. Which is the year? Is it an X or is it a Y? It's an X. So why do I know that? Because see, X's are the first column and Y's are the second column. So if I put in my year, I put in 2012 right here, then I just type this into my calculator and it tells me the answer to the question. But they have instead said, when will this painting reach $35,000 in value? Sure, they could have. Then they didn't tell me an X, they told me a Y. And I would have stuck it here. And then I would have solved for X and got X alone and figured out what year it would have been. Yes, but in general, time is always the independent variable and goes across the bottom of a graph and therefore is the X. So try to stick with time being the X. Okay, so I think that's everything that you need to know. And for today, Your homework is just going to be to finish that worksheet we gave you. That'll give you some extra time. And besides, it's homecoming, and would have been tough to study over homecoming weekend anyways. All the dances and stuff you're going to be doing. So anyway, Monday, we'll give you a little practice test and then grade it, and then you'll take it home and you can study off of that. Tuesday and Wednesday, just prepare some time on Monday night to study so that Tuesday and Wednesday will go well for you.